So let's start today's session. Today we are going to have a look at the Kotlin coroutines. So let me share my screen. We will first go through the theoretical part and then we will see the practical implementation part. And I hope it will clear the all the doubts related to coroutines. So just let me know when my screen is visible to everyone. Okay, so it's visible, right? Okay, thanks, Mayur. So let's first see what are the coroutines. So we'll go through these slides. So these are our agendas. What are the existing solutions? What are coroutines? Feature of coroutines, terminologies, some myth busters, and the Kotlin flow. I'll try to cover as many topics as I can in this session. So the first thing is why we need coroutines. Okay, so you see coroutines are the concurrency framework, right? The first question is why do we need it? Aren't we have these things called threads and callbacks and all these things? Then why to create a new framework, right? Why to put an extra effort to create that and use that and learn that? So the thing is, the existing solution have its own problems. So let's have a look at them. So the first existing solution, you can say alternative to the coroutines is a regular Java threads, right? So we are using this Java thread since long. So traditional multi-threading in a Java is a powerful tool, but it can also be cumbersome and error-prone due to its issues like synchronization and race condition, right? So what are some issues with the threads? That first thread is there are some issues like synchronization and race condition, right? For example, if your multiple threads are mutating same property at the same time, there might be a synchronization issue, and there might be some cases of the race condition as well. Okay, the race condition means sorry, means uh, the race condition means basically that the two things are trying to do the things for example same time. Okay, and the another disadvantage of the threads is the number of threads that can be launched is limited by the underlying operating system, and it's expensive as it requires context switches which are costly. So what does this line means? Okay, like you in lot of tutorials for the coroutines you may have heard that threads are expensive, right? And it require context switching. So what does that mean? So it means the Java threads, let me go to the IDE. If you see this thread class Java, it's in a java.lang, right? So this Java thread, what it does, it's just a wrapper over the operating system thread. Every operating system has the concept of the thread, right? Be it a Windows, Mac, or anything, or Linux. So they has the concept of the thread, and every process should have multiple threads. So these Java threads are just a wrapper over your operating system threads. So when you create a new thread, let's say I'm creating the thread and I'm passing some this is runnable. Okay, I'm passing it inside the lambda. So let's say let me call it hello from thread, and then start. Let me add some delay, thread dot sleep 300. So what it will do, let me move it here. So what it will do, it will start the new thread, it will sleep it. Sleep means it will block the main thread. This is another thread, right? This is a new background thread, and this thing is running in a main thread, so it will block the main thread. Then for 3 seconds, then it will print it, and then it will print this line. So if you run it, you will see that no output till 3 seconds. Okay, so you can see hello, and you can see hello from the thread. So these Java threads are typically a wrapper over the operating system thread. That means when you create a new thread, that means your operating system is aware about this thing, that your program has created a new thread. Your operating system underlying OS is aware about it, and that's why when you need to switch from background to the main thread, your JVM need to ask your OS to do it, for example, and then it will need to communicate at the OS level, right? So that's why it's an expensive operation, because your operating system is aware about it. That is another issue with the threads. Okay, and just to give you an side information, JVM 19 is introducing a project Loom that's known as the virtual threads. That act similar to the coroutines, not the same, but similar to coroutines. Like, or to overcome the pitfalls of the threads, it's known as a virtual threads. Okay, another thing is callbacks. So what is this callbacks? You might have seen this in a lot of program that uh, you pass the callback, right? For example, when you start something for your when you start another activity for result, you have something called on activity result. Like I think some of you already know about it, and you have to override this method in your Android application, right? What this means is when the result is available, your callback will be called. This is your callback you are passing there, and when the result is available, you will get your result here. Get result here. Okay, so this is an example of the callback. So, what callbacks? Why callbacks is problematic? Because sometimes, let's say, you have a lot and lot of callbacks. So, let's say, for example, inside this callback, I have another callback. On a result, and inside this callback I might have another callback on process. So this leads to a a deep hierarchy of the nested callbacks, right? It's known as a callback hell, basically. Callback hell. So it leads to deeply nested hierarchy of the callback. So it sometimes it's not even predictable like what's going on, because if, let's say, if it's a 10 it's nested down to the 10 hierarchies, it will become unpredictable to decide when will something happen, and it's look ugly as well, right? So this is another issue with the callback. We have seen the threads and we have seen the callbacks. So these are the existing solutions before coroutines were introduced. There was another solution as well called future from the java.util.concurrent package, and for the JavaScript we have something called promise, right? So what it does is a future is it guarantees that something will return a value after some point. Okay, so let's say, for example, I have this function called a return value. Okay, so let's say it makes some network request or some uh, calcu high calculation is going on. Okay, so it will definitely return, but after these things completes. Okay, and what does that means? When we call this function, we should return immediately and let this high calculation go on, and inside the return I'll return my I will wrap my return object with the future with this future interface. Okay, so this is how my a return type will look something. So this future guarantees that something will return after some point of time, right? You can see its definition. A future represent a result of the asynchronous computation. So this was also available in Java before the coroutines arrived, but you need to wrap your result in class in terms of this future interface, right? And the similarly in JavaScript we have this concept of the promise and async await. So these are the existing solutions before the coroutines arrive. So now and we have seen it, they have its own limitations as well, right? So now let's see what are the coroutines. Okay, first we'll, as I mentioned, first we will cover the theoretical part. So coroutines are the lightweight concurrency mechanism that can be used to write asynchronous non-blocking code in a more readable and maintainable way. So coroutines is again a concurrency mechanism. The thread is concurrency mechanism, right? And a framework. Sorry, this future is also concurrency mechanism. Same coroutines allows you to maintain the concurrency, that is doing the background work, for example. So it's a concurrency framework that can be used to write asynchronous non-blocking code in a more readable and maintainable way. It is based on the idea that a function can suspend its execution at some point and resume later on. So let's say we have two function, let's say two something fun test and fun test 2. Let's say we have something like this, and we let's say we are calling it something like this, test 1 and test 2. Okay, we are calling something like this. So what Kotlin coroutines promise is that let's say again high calculation. Okay, let's say again high calculation going on here and here. So what the Kotlin coroutines promise is that you can call this function, don't wait for this calculation to occur, immediately jump to the next function, don't even wait for this calculation. When this calculation will be completed, you will get your result here, and when this calculation will completed, you will get your result here, something like, well, test 1 equal to like this, and well, test 2. Okay, so once this lines of code executes, these lines of code won't wait for this calculation to complete, because if it's a coroutine suspend function, as soon as the compiler hit this line, it will create a new coroutine. We will see how to do it, and then it won't wait for the result, it will immediately jump on to the next calculation, and then for this it will start another coroutines. Now when this calculation is completed, okay, and you have your result, then you will get your result in this variable again, and you will get your when this calculation completes, you will get your result in this variable. So what's happening, when this lines is created, uh, your function new coroutines will be created for this, your function will be in a suspend state, and it will continue doing this high calculation in the background, right? So and again for this new coroutines will be created, and your function will go into the suspended state, and it will keep doing this calculation in the background. When the value is ready, your function will return to the resumed state. Resumed means you will get the value. Same for these things, it will return to the resume state, and you will get the value. So the entire coroutine things is built on this main concept, suspending and resuming. So to give you more idea, let's say for example this is a thread. If it's a sequential code, not a coroutine code, just like this, it's a simple sequential call, right? So what will happen, when you call your function 1 and these high calculations are going on, these lines won't get executed in a sequential call, right? Your thread will be blocked, and when this finish and this line happens, okay, so when your function b execute like this test 2, your thread will be blocked, it won't be able to do anything because this lines is calculating it. This happens in case of the sequential code, usual sequential code, right? This is an example of that thing. Now what Kotlin coroutines do is it suspend the function. You call this function, it creates a new coroutine and suspend the function. Now this function is started execution, it's suspended. Now your thread is free, to accept the new function. So now it will start executing this function. You can see it start executing function b, right? And when the results of the function b is and even the function b will be suspended, and when the result of the function a is available, then you can see it will be resumed, right? So you will have your result here. Your function will be in a resume state, and you will have your result. So this is all about the suspending and resuming. Now, coroutines are built on top of the threads but allow multiple coroutines to run on a single thread, which reduce the overhead associated with traditional multi-threading. So now tell me why coroutines are lightweight, okay? And this is even the most favorite questions of the interviewers as well. So why coroutines are lightweight? Because when you create the coroutines, your operating system don't know that there is something called coroutines is created. That means coroutines are managed at the language level, right? At the Kotlin level, and ultimately you manage that Kotlin, right, in your program. So ultimately the coroutines are managed by the programmer. Okay, your OS don't have idea what's going on, right? It don't know that something like coroutines is created, right? So when you need to switch between coroutines, or when you need to create coroutines, your programming language don't need to go to operating system, ask them, hey, create this coroutines, and then switch it. Your OS language don't need to do this, right? So it will save a lot of resources and lot of time. That's why the coroutines are a lightweight, right? So this is answer to the question, famous question, that why coroutines are lightweight. So it's built on top of threads, but allow multiple coroutines to run on a single thread. And as it's lightweight, you can launch lots and lots of coroutines at a single go, while you cannot do that with the threads, right? Let's say you want to launch the multiple threads, let's say around 10,000, you will probably get the out of memory error. JVM will throw out of the memory error, right? So that's not the case with the coroutines. And writing non-blocking code is essentially the same as writing the blocking code. So what this line means is, if it's a coroutines code, and if it's let this error be available now. Okay, so let's say if this is a coroutines code, you write it just like it's a sequential code, right? You write this line, you write this line, you don't need to do something like this new thread and then pass some runnables and all those things, right? You just write the code as if it's a sequential, but internally it's not sequential, right? It's asynchronous code. So this is the major benefits. The readability is high in Kotlins. You just write the asynchronous code as if it's a synchronous. So this is what this line denotes. Okay, now let's see the features of the coroutines. The first is lightweight. We have already seen coroutines are more lightweight than threads, meaning they can be created and destroyed more quickly, because OS doesn't need to be involved into creating and destroying the coroutines. The second is asynchronous but sequential. Coroutines allow you to write asynchronous code in sequential manner, making it easier to read and understand, that we have just seen. Cancellation. Coroutines can be cancelled, allowing you to stop asynchronous operations that are no longer needed. So once you started the coroutines, you have an instance of the job available, and based on that job, if you want to cancel the coroutines at any time, you control that thing. You call this job.cancel, and the coroutines will be cancelled. So let's say if you are making a network request, but you don't at a certain point you realize that, okay, I don't need to make this network request, so you call the job.cancel. So the coroutines will be cancelled, and that network request will be cancelled. So you control that thing. So it has a great cancellation support as well. And exception handling. Coroutines provide a way to handle exceptions that occur during asynchronous operation. So it might be possible that this function throws some exception, right? Let's say runtime exception. So it's with the Kotlin, it's with the coroutines, you can handle the exceptions as well. It's a bit of what I say, a kind of a intermediate to difficult topic, that is exception handling with the coroutines, but you can do that as well. Okay, so now let's see some terminologies. uh, so what is the suspend? The first is suspending function, right? So these are the functions that can be paused and resumed, allowing for non-blocking IO operations, right? So to make any function as a suspendable, right? Any suspendable means what? When the compiler will come to this, when the JVM will come to this line, if it's a suspendable function, the Kotlin will suspend it and continue execution with other lines. To make any function as a suspendable, you need to write a suspend keyword before the function, right? You need to write the suspend function. Now this function is a suspendable, and that means the JVM can, and ultimately Kotlin can suspend this function. If I don't write it, Kotlin won't suspend and resume this function, because it doesn't have this modifier, right? So to make a function suspendable, you need to mark it as a suspend one. You need to use this keyword called suspend, and immediately you will see some errors here, right? The suspend function should be called from the another coroutine. So let's leave it for now. Another terminology is a coroutine builders. These are the functions that create coroutines and provide a context in which they run. We will see this in details, all of these things. Coroutine context, these are objects that define the behavior of the coroutines. And the coroutine scope, this is an object that provides a way to manage the life cycle of the coroutines. So let's start with builders. Okay, so let's first bust some myths. Okay, so the first myth is coroutines are a replacement for threads. Coroutines are not a replacement for threads. In usual way, you can consider that it's a replacement for thread, but ultimately it's not a replacement of a thread. Okay, they are built on top of the threads, and they still rely on them to execute code, right? Because see, thread is essential mechanism to any modern programming, be it a Java or a JavaScript or anything. Okay, so thread is a OS level concept, right? So ultimately, if you want to take the benefits of the multi-core processor, you need to start a thread, right? So underlying coroutines are running on the threads, but you don't need to create a multiple threads just like multiple coroutines. The multiple coroutines can run on a single thread as well, right? That's why they are less expensive. But it's not like that. The thread concept is vanished in Kotlin, and coroutines are the gods and concurrency framework. Internally, they are still using the threads to manage all these things. So this is one thing. Another is coroutines do not magically make your code faster. Some might think that okay, we have created suspend function, we have launched the coroutines, my code will run faster. That's not the thing. They provide a way to write code that is more efficient and scalable, but it still makes careful design and optimization to achieve the high performance. So they essentially they provide a way, but you need to use that way, right? Otherwise, if you just do some basic things, it won't make it a performative. You need to adhere some principles, and this is the most widely spread myth, and even experienced developers tends to use that okay, if I use the suspend function, now this function will run in a background thread. Remember, this is not the case. If you mark any function as a suspend function, it will not automatically run in the backend thread. It will run on the caller thread. So if I create a function suspend function like this, and if I call it, I cannot from the main thread, but let's say if I call it from the main thread, this function will run on a main thread. It won't run on a another thread. So marking a function as a suspend does not automatically make it to run on the background thread. This is something you need to remember. A suspend function can be used to perform asynchronous operation, but they still run on the same thread as the caller by default. It's up to the developer to launch the coroutine in a background thread or dispatcher if they want the function to execute in the background. If I want to run this function in a background, I need to call it somehow in that way. If I just directly call it like this, it won't run on the background thread. It will run on the same caller thread. So just keep this mind, because this is something I've seen a lot of developers misunderstanding this, that marking a function as a suspend will make it run on the background thread. That's not the case. Just remember this thing. Now coming to the builders. Okay, now enough of the theoretical parts. Now let's see how you can build the coroutines. Okay, what are these things, and how to actually create it with the code. So to see, there are two worlds, a synchronous world and asynchronous world, right? So this is a synchronous world, in which everything is going synchronously. These lines will executed, these lines will executed, and then this line will executed, right? Everything is synchronously. The coroutines is from another world. Coroutines is from the asynchronous world. So there must be a gap, right? And we need some mechanism to bridge this gap between synchronous and asynchronous world. So to do that, Kotlin provide a builders. So what are these Kotlin builders? Kotlin builders are the function that used to create and launch coroutines. So let's have a look at them one by one. So the first is a run blocking. It is used to create a coroutine that blocks the current thread and until it's complete, right? So let's see. I mark this function as a suspend, right? And if it's a suspend function, that means I can call all the coroutines function from this function. So let's just call delay. Okay, so this is a suspending function as well. So what this delay means, it's a simply means thread dot sleep, like we have the thread dot sleep method, right? And for those who don't know, this is a Kotlin convention. It's just 3000. I'm using this separator. Okay, so it's similar to this. Okay, so if you call this thread dot sleep, it will make the entire thread to sleep. Okay, and it will block the thread. So to avoid that, Kotlin Coroutines has this function called a delay, and it's a suspend function. And another thing, you can only call suspend function from another suspend function, right? So this is suspend function, this is not. So you can see the errors, right? Suspend function should be called from a coroutine or another suspend function. So you can either call it from another suspend function or through the coroutines. So this is neither suspend function nor there is some coroutine builders. Okay, that's why we are saying this error. Okay, so let's use some delay. Now, this is asynchronous world, Kotlin world. This is synchronous world, basically pretty standard, the main function from the Kotlin. So, I think all of you know, but this main is simply your public static void main, something like this. You have used in Java, right? Let's say public class test and like this you usually do something like this. Okay, so this is your main function, your entry point to your program. So in Kotlin, functions have the first class support, right? So you don't need a separate class to run the main function. Functions have the first class support in Kotlin, which Java lacks, and which really important in today's programming. So Kotlin has that support, functional programming. So these both of these things are basically same. This was just for the folks with the Java background. So this is synchronous, this is asynchronous. To bridge all these things, Kotlin provide one thing called coroutines builder called run blocking, like this. And now if I move this to here, the error will be gone, right? You can see the error is gone. So why? Because this run blocking bridge, it's a it's not a suspend function. You can see it's not a suspend function, and still we are able to call the suspend function. Why? Because it's a coroutine builder. You can call any coroutines or any suspend function from the coroutine builder. So run blocking is created. We, in ideal practice, we never use this run blocking. It's just created for to bridge the sequential with the asynchronous world. In ideal practical example application or software, we don't use this run blocking. We will use another builder that we will see. But just to build and to give you some perspective from the JVM side, let's use this. Okay, so now let me run these things. uh, Let me print it here, hello from coroutine. So let's see what happens. Let's remove this. So we are calling this function and we don't even need a result, right? So let's run this and let's see what happens. What printed first, these things or these things? Okay, so now you can see you can see and that it waited for 3 seconds. Let me give you an example. Print ln waiting for 3 seconds, and let me run it. These lines will be printed first, this next second, and then this one, right? So let's see, waiting for 3 seconds, and then it will wait, it will print this and then print this, right? Because what this run blocking do, it bridge the things. So until the everything inside these things, until the everything inside run blocking finish execution, it won't move on to the next line. Okay, so now let's move this run blocking from here to here, something like this. And we don't need this args, right? But let me keep it. Okay, so now what we are doing, our print ln hello is inside the run blocking as well. So now let's see what happens. Let me run it. Waiting for 3 seconds. Hello from the coroutines and hello, right? So inside the run blocking, these things called sequentially, right? This one, this one, and this one. So now you can see that we made this function as a suspend, but it's not something that it's returning from this thing, right? And it's a was working like this. It's a sequential, then delay, then print coroutines, and then print hello. So it's working like sequentially, right? So this run blocking just used to bridge the gap between synchronous and asynchronous worlds. Okay, so this is one builder. Another builder is a launch. Okay, so launch is used to launch a new coroutine that runs in the background. Okay, so now let's say we want to run these things in a background. So let's use the launch block and call this function from the background, something like this. Okay, so now let's see what happens. Okay, see hello waiting for 3 seconds, and then hello from the coroutines, right? See the difference. See, let me again show you. It will print this line first, then this, and then this. Why so? Because when the JVM come to this line, it will show that launch, right? So it will go to this line. Launch means it will create a new coroutine. It will create a new coroutine. When the new coroutine is created, that means it will put this value on a suspended state, right? The functions will be suspended, and whenever we need to do something on the function, it will be resumed, right? So as soon as this line is called, the function will be suspended and the flow will go to the next line, right? So what is the next line? This one. So the new coroutines will be created and the flow will go to the next line, right? So it created new coroutines and print this line. You can, so that's why you can see the hello first, right? So now coroutines is created, so it will print this line waiting for first line. It will give some delay and then it will print this line, right? So this is how you can create your first coroutines. You can use the launch block. This is known as the coroutine builder. So you can use the launch block to call this coroutines, right? To launch your coroutines. We have seen in the case of run blocking, just merely marking function as a suspend won't do it, right? Let me again show you to reiterate. This will act as a kind of a sequential code. Okay, these things will get first, this second, and then this is the last one, right? Because even if we have made this suspend, we are not calling it from another coroutine. So to run it in the background, you can use this launch block. And in Android you have also seen this, right? Yeah, yesterday we have seen that view model scope dot launch like this. So this launch is the same of this thing. We will see the scope soon. Okay, so this is the launch function. So it's a coroutine builder. That means it will launch to it will create another coroutines and launch it and mark the function in suspended state. Okay, now let's say I have some let's say I have some value. Okay, let's say this function return something like this. Let's say return hi. Let's say we return hi from this function, right? Just consider that we return the hi from this function. So how do we print it? Okay, so let's try these things. Well, message equal to something like this, and print ln message. So let's see if we get something like this. Hello waiting for 3 seconds, and then hello from the coroutines, and then we have the return hi, right? So now you can see we can access this message inside the launch block, right? Now what if I need that message here, right? What if I need that message here? So outside the launch block, right? So this is the one thing you need to remember, that launch blocks are used to create coroutines with the fire and forget manner. What that means is if you have some functions that you don't want to return some value, use the launch block for that. Okay, so launch blocks are used for the coroutines that are a kind of a fire and forget. You just launch it, you just forget it, right? Forget means whether it will perform the operation, but you are not expecting anything in return. from that coroutines. If you are expecting the returns from that coroutines, from that suspended function, you have another block called async. Okay, so you can see this async, right? So what this async return is, you can see, where is this, it's written something. See, in on the loan side, it only returns a job, so we'll see about job later. But in async, it's written something called a t and a deferred, wrapped in type t, wrapped in a deferred object. Okay, so if you need something like that, so what you can do, you can call a test, well, my async, you can do something like this, and then you can access it anywhere outside the async block as well. My async dot await. Okay, so if it's a async function, if you are expecting something in return, you wrap your function inside async block and you call the await function, right? Because what this will return, control shift p, it will return a string, because this return a string wrapped in a deferred object, right? And to get the actual value from the deferred object, you need to call the await, right? So this way, let me do it something like this. And let's say now you don't need to read that things inside the async block, you can read it outside anywhere as well, right? So you can see waiting for 3 seconds and hello from the coroutines, and then hi, like you can see the hi and you can see the hello, this finally last one, right? So one thing to note, just I think someone has question.
Yeah, that's me, Rajesh.
Yes.
So currently we are using run blocking and we are using the async, right? So but let's say in our view model we don't have like a we don't want to use like a run blocking and we wanted to still get that value from the async await method. So how do we proceed with that scenario?
You see, this run blocking you never use in a Android, right? Because this is to bridge the JVM synchronous with the Kotlin asynchronous. In your Android application, you have scope available at everywhere. In activity, you have lifecycle scope. In view model, you have view model scope, right? So you have that
Mhm.
Kotlin scope available, so you don't need to use this run blocking. It's just to bridge the JVM synchronous with the coroutines asynchronous. In Kotlin, you
Mhm.
don't need it, and you can still use the async and await this way, right?
Uh, so my question is, Rajesh, like, so in the the print ln line, right? We use like my async dot
Mhm.
await, right? So if we are not using run blocking, then how we can like get that value? So we can use like a scope or something.
See, that's what I'm saying. You don't even need to use the run blocking in inside your view model. Let's say if it's a suspendable function, if it's suspend function, you can just directly call the, sorry, just give me a minute. If it's a view model, you have your view model scope available, right? View model
Yes.
scope, right? Dot, and you can launch the things inside that as well. So
Hmm.
you can call your async here as well and get the value. Okay. So, but if it's something more in detail, we will, let's first finish these things, and then we will discuss it. Okay, because first
Okay.
let me finish these things. Okay, now you see, now what you have noticed, these lines won't be printed first, just like the launch. Okay, see, it's waiting for 3 seconds. Hello from the coroutines, hi, and then finally hello. Why? Wrapping your suspendable function inside async does not immediately start the coroutines. Okay, it does not immediately start. It's just not that, okay, this is coroutines and I need to start. The execution is only started when you call the await function. You call the await function, right? So when you call this function, then the execution will start, and then these lines will be printed, right? To tell you, give you an example, hello one, and hello 2. Let's see, what it prints. Okay, so it will print hello 1, because see, it's not started the execution yet. It will start the coroutines execution when you call the await functions. So you have all of these lines here like this, and you are printing that line as a high as well, and then the hello 2. So this is the difference between launch and async. Launch will launch a new coroutines as soon as you call that block. Async won't do that. Async will start the new coroutines. Basically, we will start executing it when you call the await method. And another important thing is use the launch for the fire and forget types of command. Let's say if you want to make some network request and you don't care about its result, so use the launch block. If you have some results that you need to wait, call the async block, right, and get the result via the async block. So these are some coroutines builder. You launch the coroutines this way. And now, where is my cursor? Okay, now let's see what is a coroutine scope. So Coroutine Scope is an interface that defines a scope for the coroutines. It is a way to keep track of all coroutines that run it. So let me first introduce the concept of the structured concurrency. Okay, and you might have heard about this word as well, that coroutines provide structured concurrency. So what is it what is the concept of the structured concurrency? So let's say I have one parent coroutine. Let's say I have parent coroutine 1. Inside that parent, let me quickly create a sketch file. By the way, it's alt control shift and insert button. Okay, so let's say we have parent coroutines, and inside we have child coroutine 1, and inside the and we have, let's say, inside the parent we have two coroutines. Okay, let's say this is the parent, and inside we have two coroutines, something like this. We have, let's say, two coroutines. Let me just comment it out. So let's say this is the parent coroutine. You can see it provides a coroutine scope, right? In this text, it's a coroutine scope. So coroutines provide the structured concurrency. What does that means? If you have parent coroutines and it has two child coroutines, if you cancel the parent coroutines, all these two childs will get cancelled as well, right? If you cancel the parent coroutines, all both of these two childs will get cancelled as well. So it has a structured hierarchy. It's a parent, then it's a child, then it's a child, right? So you control the concurrency of all of these things. If you cancel the parent by calling the parent dot cancel, it will cancel the inner child as well. This child won't finish their execution. There are ways, but by default it won't finish this child. It will cancel this childs as well. So now you can see, you can control your concurrency in a structured manner. You have parent, you have child, then inside you have a grandchild coroutines 1 as well, right? So if you cancel this, all of these things will be cancelled. If you cancel this will be cancelled as well. So now you can see the concurrency is in a structured format, right? Nested in a one by one level. So this is the something that coroutines is built upon. And coroutine scope is an interface that defines a scope for the coroutines. Okay, so what is a coroutine scope? It's an interface that defines a scope, and all coroutines, any coroutines must run inside a scope. Any coroutines must run inside a scope. Let's say if you want to start some coroutines here, you will need a scope here. If you want to start coroutines without scope, it's not something you can do it, right? So that's why if I remove this run blocking light, I don't have any scope, right? So I cannot launch this coroutines builder because I don't have any scope available. If I use the run blocking, it provide me the scope. See, it provides me the coroutine scope, right? You can see it provides me the coroutine scope. So all the coroutine must run from the coroutine scope. You must have at least a scope. And what this scope do, this scope manage all the child coroutines as well. It's keep of the track of the coroutines, like what uh, whether these things, what these things is doing, what these things is doing, what if I want to cancel it, what if I want to cancel it. That related things is managed by this scope. If you cancel this scope, let's say you have, let me give it a name, scope. Okay, so we have this reference, right? So if I call this dot cancel, let's see, we have launched two coroutines. Okay, inside what we have done, we have launched the two coroutines. So it should print all of these things two times, right? So let's see how this works, and let's see if we get something or not. Okay, so you got this, and you can see exception in a main thread, job cancellation exception. What is this? Blocking coroutines was cancelled. See, issue, see the issue, what the issue is here. We have launched a coroutine, we have launched another coroutine, that means two coroutines. Let's just remove it for now. Okay, so in from the parent we launched the two coroutines, and now we are canceling the scope by calling, we have a scope available as a this reference, and we are calling this dot cancel. If the parent scope is cancelled, child coroutines will get automatically cancelled, right? That means it's, see, you can see it's throwing an exception, that the job cancellation exception, the job written by this job 1, this, and the job written by this coroutines, has thrown exception that this job is cancelled, right? Because we are prematurely cancel before the start, before completing this coroutines, we are prematurely calling this dot cancel on this scope. So that's why it's canceling all of the child coroutines as well, and you can see this exception as well. And this lines is ultimately it's printed, this printed first, right? Because all of these things will just launch a coroutines and move on to the next line, right? So this is the concept of the scope. Scope is something that manage every child coroutines, and it keeps the track of it. And you need a scope to start the coroutines. So coroutine launch within the coroutine scope can be cancelled when the scope is cancelled, right? And you can manually cancel any job as well. So let's say job one dot I want to cancel it, I can do that as well. So this is the scope. So let's see what will happen. So now the job 1 will be cancelled, and you can see hello 2. So it printed only this for the one time, right? But here we are calling it two times. So what it did, it launched a job, a new coroutine, then it launched another coroutines, then we are cancelling the first job, we are cancelling this first child, right? We are cancelling the first child, and we have cancelled this job, that means we have cancelled that coroutines, so it won't execute these things, right? And this job 2 is, we are not cancelling it, so it will run as expected. You can see the 3 line outputs, right? And these things will be printed first, because this is the asynchronous code, right? Making sense for everyone what we are doing here? Hello, are we calling job 2 with that reference? No, we are just calling the job 1 dot cancel. So the launch will return a job, and you can manipulate that job. Basically, you can control that job. Initially, I was discussing about the coroutine scope. This is not about the coroutine scope. It's about the job written by the coroutines. If you call this dot cancel, it will cancel the parent coroutine, because it's a parent coroutine, so it will cancel all the child coroutines as well in the first case. In this case, something like this. But now if I comment it out, and if I called job dot cancel on this job, only this execution will be cancelled, this won't, this will run as expected. So you can see 3 lines printed out here, so this job won't be cancelled, right? So this is how it works in a coroutines. And another things I wanted to show you, let me show you run blocking, that see we are what happens is, you can see the exception, right? Another most important thing to remember in coroutine is exceptions are propagated. What does that means? If your child coroutine one throws any exception, let's say throw exception, if it's throw exception, it will be rethrown by your parent as well. This exception will come to here, and this will again throw it as well. Exception will be propagated to the parent. So now you can see if this job is cancelled and exception is thrown, your parent has also thrown it. So you can see exception on the console, right? So in the coroutines, exceptions are propagated until you use the supervisor job. That we are not going to discuss today, right? But you can use that supervisor job to let your child coroutines spelled independently. So this is the coroutine scope. So basically it manages all the things related to its child coroutines. Provides a way to manage and control coroutines. We have seen that. And they are a way to bind coroutines to any application specific lifecycle. Easy view model scope in Android to avoid leaking. So what is this view model scope? It's a coroutine scope, okay? And you can create your own scope as well. Let's say I don't want to launch I don't want to use this run blocking scope. I want to create my own scope. Let's say let's call it a my scope equal to coroutine scope. I can do something like that as well. What I need to pass it's a context. So for the coroutine context that we are going to discuss soon, for the context, let's can we create a context directly? Does not have a constructor. Okay, so okay, we have this context as well from this thing. So I can create my own coroutines as well. So my now I have my own scope, and if I launch this inside my scope dot launch, right? If I do something like this, right? So now this launch refer to my own scope and not the ones provided by the run blocking. Okay. So now this is the child for this scope, and now my launch is running inside my own scope. The view model scope you see in Android or any life cycle scope created by similar this kind of commands. You can create your own coroutine scope like this way. So your view model scope or your even your life cycle scopes are created like this way. You can create your own scope as well, right? So this is all about the coroutine scope. Without scope you cannot launch coroutines. Now what is the context? Okay, so coroutine context is an interface that defines the context in which a coroutine runs. Okay, so it can include information such as coroutine's job, dispatches, and exception handler. Coroutine context provide a way to configure and customize coroutines. Example, dispatches.default main IO and unconfined. So what is the context? So context is where your coroutine should run. The your scope, coroutine scope manage
Yeah.
that. Okay, I think someone is getting bored. Maybe I believe. Okay, anyway, so uh, your coroutine scope manage all the things related to your coroutine, be it a cancellation or anything. Now, where to run these things? Okay, I have created this coroutine, and we have seen that coroutines are ultimately runs on the thread, right? So where to run it? Uh, be, be it run on IO thread or a main thread or a default thread, where to run? That things you can provide via the coroutine context. So you can see each coroutine builder takes a context as well. If you pass it something like this, you can say it accepts the coroutine context, right? And if you don't provide it, the default is empty coroutine context. So let's say let's take an example that inside this let me call another function, suspend function. Let's say it's named as a make network request. It's named as a make network request, and here I am making network request. Okay, we are thinking in terms of Android. Okay, so let's say let me use a delay to make the use of the suspend keyword. Okay, so we are uh, print ln network request successful. Okay, so now this what this function is doing is making a network request, right? So it's better to offload your network request on IO thread, right, better than the regular main or the default, because IO threads are optimized for IO operations, be it a network request or reading from the database, etc., right? So what you can do, you can provide your a coroutine context here, and this is also known as a dispatchers, right? So you can call the dispatchers.io, you can call these things. So now these things will run on IO thread pool, and this will run on a unconfined. Basically we are not providing anything, so it will run on a unconfined. So but this will run on a dispatchers.io. In the output you won't be see any difference, but the things, oh, we are canceling this, let me just cancel it. So the output will be simpler, but this time this code will run on a IO thread. It will see, it will be printed two times because we are calling the two coroutines, right? So these things will run on a IO thread, and this will run on a unconfined, basically thread. So we have multiple options like default, main, IO, and unconfined, right? These are the multiple dispatcher options. So if you make the network request and if you don't provide anything, it will still make the network request in the background. But if you provide the dispatcher.io, your network request will efficiently use the IO threads that are specifically designed for the IO operations, that is input output operations. So better to use the dispatchers.io for anything that you make use of the IO. Okay, so this is known as the coroutine context, and it's also known as a dispatchers. So two things, scope and the context. So what scope means, scope manage, basically you can see that scope manage all the coroutines, and it keeps track of all the coroutines. What is the context? Context decide where this coroutine should run, be it on IO thread, main thread, default, or unconfined. So context manage where your coroutine should run. Okay, so this is all about the simple funda about the coroutines. So, and this is how it works. We have seen about the jobs as well, we have seen about the coroutine scope as well. So this is how coroutines works using the suspend and resume mechanism. Okay, so if you use if you want to fire and forget operation, use the launch builder, or if you need some result, if you need to retrieve some result, use the async block like this. Okay, and if you use if you call multiple launch block, all of these two things will run in parallel. Okay, and another misconception I wanted to clear is, you might even read this on internet, that for parallel operation you need to use async. That's not the case. Okay, even the launch provide the parallel operations as well. You have this scope, and now we have run the two coroutines using the launch block. So both of these things will run parallelly. Okay, it's not something like that only async can provide parallelism. Even the launch can provide parallelism as well. You need to call it multiple times like this. Okay, so that is one thing I wanted to highlight as well. Now someone asked about the flow and state flow in group, so let me discuss quickly that as well. So okay, so what the flow API is, basically flow is a stream of data. Let's say let me create a function called new Kotlin file, and let's call it the flow example. Okay, let me call it a flow example. Let me create the main method, and now let's say fun return value. Okay, and return list of the, let me return a list. Okay, so 2 1 2 10 dot to list. Okay, let me just return it. So what it's returning, it's returning a list of the integer. So let me just, let's print it, and see how I get it. So let me call the return value dot for each. I'm iterating over them, and then print ln. Basically, let's just skip it for now, and print ln return value. So this is our usual program. Okay, this is our usual program in a regular program. Okay, so what we are doing, we have a function that returns a list of 1 to 10, and then we are just printing it. So how things will work here? It will first create a return of 1 to 10, 1 2 3 4 5 6 7 8 10. Then it will convert it to list, and then it will return the whole list, wholly created list, to your caller function. So this is how it works. Now what if I want to get the value as and when it's created? If the one is computed, just give it to me. Then you compute two, but don't make me wait. In this case, it's making us wait. It's a create two, then it's create three, then it's create four, then it's create four up to 10. We have to wait it. This function have to wait it until this list is created, and then it's giving the entire list. So this is our regular program. Okay, and we have to wait it. Now this is kind of a barrier in asynchronous programming, right? In asynchronous, what do you expect? Hey, just calculate it and give me as and when you calculate it. So to provide a stream of the data, instead of sending all the things at a time, you want to send the things as and when it's calculated, and let's not call her wait. To handle these things, Kotlin introduced these things called Kotlin Flow. So Flow is a library for asynchronous stream processing in Kotlin. So it allows you to emit a stream of values asynchronously and handle them in a sequential manner. Flows is built on top of coroutines, making it easier to integrate with the existing Kotlin based code. So to create a flow, let's say one return flow, there are multiple things as well, but you can use a flow builder called a flow, something like this. And inside the flow, what you do is not enough information. Okay, so let's say uh, 1 to 10 dot for each emit whatever you want to return, you need to emit it. Okay, whatever you need to return, you need to emit it. So what we are doing, we are creating a list of 1 to 10, and as soon as the things are created, we will return them through the emit. We will emit it. Basically, emit means we are just returning it with this flow builder. So now to get that value in the main, what you need to do is you need to return flow, you need to collect that flow. Okay, return, here we are emitting the value, and inside the caller we need to collect it, right? We need to collect it, and as you can see, this collect is a suspend function, right? Because this is coroutines, right? So it's a suspend function, you cannot directly call it. So let me call the run blocking again as well, something like this. Now we can get the value one by one. So let me give you an example of what I mean. So if I run it, you will see the same thing. But I'll give you a more clear example once this run. So we get the value, right? So to give you an example that we are actually getting the value as soon as it's created, let's call this delay of let's say 2 seconds. Okay, now you have idea. Once one is calculated, you will get the one, you will wait for 2 seconds, then you will get the two, three, something like this. Okay, so now we are essentially getting a stream of the data. One, then it will wait, then it will provide two, right? It's not creating the whole list at a time, it's creating element one by one and returning it, right? So this is the main advantage of the Kotlin flow. Initially, it was, before the flow, it was available with Rx Java as well, but the flow changed the game, and it's now a go-to destination for Kotlin developers for asynchronous stream processing. So you can say we are getting the data in terms of a stream, right? We are getting things one by one instead of getting the whole things at a time, right? And you can from the flow you can emit it, and from the in on the caller side you collect the flow. So flow is basically stream of the data that you are getting one by one. Okay, this is how the flow works. Now, what is the state flow? State flow is a type of the Kotlin flow that let's move on to another thing. State flow is a variant of the Kotlin flow that represent a value that can be observed and updated. State flow is designed for use case where you need to observe value and react to change in real time, such as updating the value based on the user input. So, what is the state flow? This is a flow, right? Flow is a stream of data, and flow is a cold flow. What does that mean? If I don't let me tell you one thing. Print ln sending value. Okay, so before sending each value, we will see this thing called sending value, and then let's call the print ln end. Let's call it end. So now let me reduce it to 1 second. So now let's see what happens. Let me again rerun it. So before sending each value, it will print that sending value, right? Sending value 1, sending 2, 3, 4, 5, 6, 7, 8, 9. It will send up to 10 value, and then it will print the end. Okay, you can see the end, right? Now flow is cold flow. Cold, okay, there are two types, hot flow and cold flow. What does that mean? If I don't call the collect function on the flow, it won't even calculate these things. Okay, so let me just do something like this. Return flow. Let me just return flow. I'm calling that function, but I'm not collecting that flow. So see, let's see what happens now. You can see end is printed, right? This things is not even initiated because I'm not collecting that flow. This is called, in terms of asynchronous world, this is called a cold flow. Okay, this is called the cold observer. In observer subscriber pattern, this is known as the cold. Okay, so because if only I collect it, then it will execute all of these things. If I don't collect it, it won't execute these things. So now this is known as the cold flow. Another variant of the flow is a state flow. State flow is a hot flow. So what is the state flow? Flow returns the value one by one. So what is the state flow? State flow is not like that. State flow is not a stream of the data. Rather, state flow at a time holds only one value, and when the value gets updated, you will and the value gets updated, your observer will get notified about it. Let me try to see if I can give you an example of the state flow in this JVM world, because right, we use it a lot of time in Android. But let's see if I can give you an example of let's say, well, my let's let's call another function called well, how do I do it? Okay, to give you an example and update the things here using the state flow. So basically state flow is a value holder class. So let me tell you like this way. Well, my flow equal to mutable state flow. You have state flow and mutable state flow as well, right? And it requires a initial value. So let's say it's a zero. It's initially it's a zero, right? So now uh, let's say it's a zero, right? And then what we do is my flow dot collect. Let's collect it. This is I'll give you an examples. Okay, so what is this function? Invocation collect expected. Okay, okay, so I'm collecting it, and what I'm doing, println collected uh, value is it. Okay, or let it called a value. I'm just trying to give you an example of the state flow. So let me set up it. Then my flow dot value equal to 1. Let me call it something like this. Then let's add some delay here of 2 seconds. Again, let's add some 4-second delay here. The program won't close. So let's comment it out as well. So let's run it. If it runs successfully, I'll show you how it works. Collected value 0. Collect. Okay. So maybe it's not working as expected because after the collection, it's not going forward, right? After the collection, it's not going forward. So this is the limitation here I have. Okay, so all of these things are running collected. It's collected one value. So I have some limitations here. I can probably we can provide StateFlow in JVM as well, but I don't have a concrete example in mind to give you. But this is how it works. It's a, let's say for example, it's a StateFlow. You provide the initial value here, and you collect the flow from the other functions or other files. You collect that, and when the value is 0, you will get the collected value as a 0, and somehow you change this value from 1 to 0 to 1. So you don't need to do anything. This collect will automatically get the new value. This state flow, this is a StateFlow will automatically tell its observer that the value is changed and now it's a 1. So you will see 1 printed here. Okay, so this is how StateFlow works. The flow, what the with the flow case was that with the flow is sending a stream of data. StateFlow is not sending a stream of data, it's just sending one data at a time. So now it's 0. If I don't update it, it won't update send any value here. Only when I update the state flow, the updated value will get will provide it to their collector, basically to its observer, right? So state flow is a hot flow. So even if you don't collect it will start emitting the value. If there is, even if there is no collector, it will start emitting the value. And state flow is used as a value holder class, just like live data. I think if you are, even if you are from Java background, you may use the live data in Android, right? Live data is just a value holder classes. So same way, the state flow is a variation of the flow and use as a act as a value holder. Okay, so it will emit one value at a time, and when the value updates, it will update its observer as well. Okay, so thank you, and this is all I wanted to discuss for the Kotlin coroutines, including its scope, context, and flow API as well. Now we are open to questions. If anyone has any questions, you may ask. So
Hello.
yes, okay, okay. Let's first go with this scenario. Okay, Tejaswini first.
We have something called shared flow as well, right? So
Uh,
what is the difference? Yeah, what is the difference between like in which scenario we will use the state flow and the shared flow?
uh, yeah, please. You wanted to add
I,
something.
out of my knowledge, like shared flow, we use it to to send and collect the events.
Mhm. So you can say a hot flow that share emitted values among all its collector in a broadcast fashion so that all collectors get all emitted values. So what you said, I haven't used it practically on any project shared flow, but I can say that uh, let's say if you have a flow that you are sharing between multiple observer. Yeah, let's say you have a three observer, right? So they are observing the same value. So to for that use case, instead of using the state flow, use the shared flow, and whenever you update the value, all of your three observer will get the updated value in a broadcast fashion. This shared flow will broadcast the new value to all of its observer, be it a 3 or 4 or 5. So if you have a multiple observer attached to that flow, better to use the shared flow. Okay.
Okay.
Okay, Arpit, please.
So, hi Rajesh, let me start with the flow. So, for my first question, I have is like,
Mm-hmm.
so if you create like a state flow, and if you wanted to do like collect for multiple places, how can we do that, or is it possible?
Okay, just like based on the things that I told, right? Like you can
Yes.
collect something like this. Yeah, so you can again you can collect the mutable state flow as well, let's say multiple times. But the things that I just mentioned, because I'm saying this because I haven't used the shared flow practically. Okay, so I don't have actual knowledge about it. But based
Mhm.
on the description, I believe that it's something like for this use case, you it's better to use a shared flow. You can still collect the state flow multiple times as well, but I believe the shared flow is designed for that use case specifically. But still you can do that as well. And I
Okay.
don't have concrete hands-on with the shared flow.
Mhm.
Okay.
And the second question I have regarding the coroutine. So let's
Okay.
say I have like a two coroutines,
Okay.
and one coroutine is dependent on another one.
Mm-hmm.
So if I wanted to cancel one of the coroutine, I wanted to cancel all the coroutines within that like a parent coroutine. And vice versa. Like if I wanted to cancel one of those coroutine, I don't want to cancel other coroutines that within that parent coroutine
Mm-hmm.
scope. So
Mm-hmm.
how do I achieve that kind of scenarios?
Uh, okay, so to cancel, let's say this is a parent coroutines and these are the child coroutines. Okay, so to answer your question, let's say you want to cancel independent coroutines and don't want to cancel the other coroutines. Okay, you want to let them run. So you create a job instance just like this. This launch will return a job instance, and if you want to cancel it, you can manually cancel it like this job.cancel. So this will only cancel these coroutines and not this one. This will continue running as usual. So
Mhm,
if I understood your question correctly, if you want to cancel independent coroutines like this, you can call the job.cancel like
mhm.
this.
Oh, okay. And how do we like catch that exception and so to the UI? So basically, I wanted to get that exception.
Yeah, so to catch the exception, it takes the exception handler as well, I believe. Empty coroutines. Let me see. Well, handler equal to
Coroutine exception handler.
coroutine exception handler, right? And we have this exception what it requires. Let me see. We have this coroutine exception handler as well. Handler coroutine context. It requires context as well. So maybe empty coroutine context, and for the let me see what's the issue is. Input type, let me try dispatches. Maybe no, it's not available. But you construct your coroutine exception handler, and you pass your exception handler to your scope. Okay, let's say for example, well, my scope equal to coroutine scope. Where did that went? I think I've seen it somewhere that you pass the coroutine exception handler as well somewhere, but I'm not able to find it right now. Dot.
While launching the coroutine, launch of dispatcher plus io plus by scope, the sorry, the
Handler
exception handler. Yeah,
like this,
and
yes.
we need to define the exception in the coroutine exception handler constructor.
We need to define the handler. Okay, so uh, cross inline handler and coroutines
Exception.
context and throwable. So we are basically, I think we are getting it coroutine concept and the throwable. So uh, context and t, maybe something like this. Okay, so we this is how you define your coroutine exception handler, and you decide what to do. You can decide it here as well, because this is throwable, right? You can check that what exception type is, and you can provide your let me rename it handler. You can provide your coroutine handler along with your launch dot your dispatchers and your handler, something like this. And you can handle your exception here as well. Let's say handle exception here. Okay, so this is how you can sorry, you can handle exception here as well. So this is how it works. Okay,
Okay,
thanks.
so like,
Yeah, please.
sorry, Rajesh. So I just wanted to clarify one more thing before we
Mm-hmm.
go. So let's say we have like a three coroutines. We
Mm-hmm.
have coroutine one, which is containing coroutine two and coroutine three. And if I wanted to cancel that coroutine one, so it will cancel all the coroutines. So in that case, I need to create another coroutine handler.
So what's your scenario? You have, let's say, parent, right, and a child,
Yes,
and
yes. So
and
let's
now.
say I just wanted to, yeah, I just wanted to cancel the parent coroutine one.
Okay, so if you cancel it, the childs will get cancelled as well, right? Because this is how you, because
But
even okay, yeah, please.
sorry. So child coroutine 2 has some exception. So
Okay,
how do I catch that in like a parent coroutine?
so you don't need to see you if these things throws any exception, it will it won't be like a suppress. It will be thrown to your parent. It will be propagated to your parent coroutine. So you can pass so you can handle the exception here as well. Let's say for example, if it throws something, I can try something like this,
Mm-hmm.
and it will be thrown to your exception, and so it will be propagated to your parent as well, right? So you can catch something like this, because it won't be something that if it's created, it will be suppressed. It will be thrown to, because we have seen in the case of these things, right? it's
Mm-hmm.
it's it's a thrown to, it's propagated to your parent. So you can try something as well. Okay, and
Okay.
one another important thing I wanted to tell you, it's not related to your question, but it's something I wanted to tell, that if let's say, for example, if you have your parent coroutines, and if you have multiple coroutines, if any of the coroutines throw any exception, the whole things will get all of these things will be failed, right? Even if
Mm-hmm.
only these things failed, you on these coroutines and your parents will cancelled as well. To avoid it and to let your child coroutines failed independently, what you can
Mm-hmm.
do, you can create a supervisor job, that my scope equal to coroutine scope. Let me create it. This dot just use coroutine context plus supervisor job. So if you create your coroutine scope with the supervisor job, what it will do, it will make sure that your coroutines failed independently. So now if you call something like this, launch, and again, let's say it throws exception, and
Mm-hmm.
my god, it throws, it does not throws exception. Okay, it doesn't throw any exception. So now if you have used the supervisor job, your child coroutines can fail independently. If even if it's fail, this will continue working, and ultimately your parent coroutine will keep working. It won't be that the exception is propagated, so entire things will be held down. So this can fail independently, and this can continue running independently and finish its task. That is the main
Mm-hmm.
benefits of using the supervisor job.
Supervisor. Okay. Thank you, Rajesh. And one more quick last question. Sorry,
Mm-hmm.
regarding the flow. So let's say I have like a flow list of user IDs,
Mm-hmm.
and I wanted to get another API call and get another flow, which is like details of that user.
Mm-hmm. So you can
And
but okay, yeah, please finish, then I'll answer.
yeah, so on that scenario, like I wanted to return the list of the user details.
Mm-hmm.
So how I can like create like a such kind of flow?
Okay, so you can wrap flow inside flow as well, but what you are discussing, I think you don't need another flow. So let's say you are getting the flow of the user ID, right?
User IDs,
That
a list
means
of user ID actually.
okay. So let's decide it's a list of the flow or just a flow, because if it's a, let's say if you have a list of user ID, so you can
Hmm.
convert it to the flow of the user ID and you will get the one user ID at a time, right? So if you have a list of the let's say one, two, three, four. So if you convert this list to flow, you will get something like this if it's list to flow. So you will
Hmm.
get the one user ID at a time. So in this case you don't need two flows, you one flow is fine. Dot let me tell you, this is a flow dot collect, and inside this collection, well, details, you just get the user ID and get user details. This is just another suspending function. So you can do something like this. You can get the user detail like this. You don't need multiple flow for that. One flow is fine. This initial flow is fine. You get the list of the user ID from this flow, and for each user ID you want to retrieve the user ID. So just call another suspend function. That's fine. But you don't need two flows for that, if I understood your
Hmm.
question correctly.
Mm, but I want like a flow that returns the list of user details, right? So I
Hmm.
have like a, let's say I have a screen that I wanted to do like a suggestion for the user. When user types something, I
Hmm.
wanted to display that list, that updated list from the API.
Hmm.
So in that case, I need to return the list instead of the single user detail, right?
Yes. So even so flow, yeah, flow can return the list as well, but at that time the list will only, for the flow, that list will be only a single emission. So
Mm-hmm.
once it's emits, it will finish, right? Because you have
Mm-hmm.
emitted your list once at a time. You are not emitting single elements, you have emitted whole list at a time. So after the emission of the list, the flow will gets completed because it has only one element to emit. And but if you are asking that flow inside flow, you can do it, and you can collect that thing as well. You can use basically, you can collect the flow inside flow, something like that. Let me show you if I can return flow another. Let's say it's time, let's say it's keep it up to 1 2, sending value, let's say called it. Let's call the emit function here, emit, and let's do it something like this. So inside, where we are collecting it, inside this flow, no, not this one, where is, okay, we are collecting it something like this. Let me first cancel all these things and then return value, let's call it 2. It's better to use the 2 here, and 1. So 1 and 2 dot collect and print ln inner, something like this inner. So let's call it outer. So let's see if we are able to achieve it or not. Okay, so we are collecting the flow inside a flow, right? We are, this is in inner flow, this is a outer flow.
Yeah, but like in our current example, we have just the list of items, right? Like the list
Mm-hmm.
of integers, and we are emitting that value one by one.
Mm-hmm.
But in like my scenario, as I described, like we have like a one API call which is return like a list of users, and
Mm-hmm.
on that, depending on that list, I wanted to do like a single API call, and it will return user details, and then I would like
Okay.
to return like a list of user details.
Uh, so to replicate,
I mean,
may
it's
maybe, yeah, yeah, please.
yeah, sorry, I don't want to take much of your time, Rajesh, but I have like a demo example that we can go through like offline or something.
Okay. So you wanted to do something like this to list. Let's say, is this your use case? Like emit a list of the values,
Yes, yes,
right?
yes.
And we are what is this? We are collecting it here, right? We are collecting the list of the value. So here we'll get the list, right? So now
Hmm.
inside, what you want to do? You want to make a network request for each uh,
Each
each
user ID, yeah.
each user. Yes. So you can called outer dot for each and outer dot for each because this is list, right? And
Hmm.
you can make a network request something like this. So make network request for item. So you can do it as well. So this is what you wanted, or am I still missing something? We have the list, we have the each item, and we need to make a network request. So yeah, you can make a network request, but I think
Hmm.
maybe I'm missing anything.
So the last part is you got two part, right? The last part is basically returning that detail list. Now I wanted to combine that with whole list and display it to the user. So basically, like I just wanted to combine each network response and
Okay,
make
okay.
like a list.
Okay, so to do that, you can use well my details. You can say well my user details, and what you can do is you can use here. Let's say for example, you can use a mutable state flow, something like this, to let your use UI aware about it. And here let's say a map of the user ID that is a string. Let's say for example it's a long, and then there details. Let's say for example a long, and then the details. So detail is a user variable, so it's a map, right? So you have your
Mhm.
user ID and along your user, right? So when you have all things ready like this, you can update your state flow. You can update your state flow here, like update state flow. And when these things is updated, you will observe these things in your UI. So you will have all these things available to show to your user.
Okay.
Okay, but if you are
Mhm.
still missing something, let's discuss it offline, and then we'll try to sort it out.
Okay. Thank you, Rajesh.
Yeah, thank you. Okay, anyone else wanted to ask anything? Harish, Samir, Aditya, Mayur, Tejaswini, Girdhar. Okay, so I think no more questions, and I hope this will introduce you with the Kotlin coroutines as well as the flow world, so you won't have difficulties when we use a state flow and flow and all these terminologies like scopes and launch and asyncs, right? So with that, I think we have another question. Check Giridhar message. What is this? What is if a coroutine has a two child, is it necessary that both of the childs run on the same thread? No, it's not necessary. It might coroutine might schedule this on another thread and this on another thread as well. So it's not guaranteed this both of these things will run on a same thread. It might run on a different thread. Okay. So I think it does answer your question, but we are calling job 2 with that reference. I think we have already answered this as well. This is about exception handler. Thank you, Tejaswini. And supervisor scope and check Giridhar's message. We have answered that. Okay, so with that being said, uh, I think we can wind up this session, and we will meet in the next session to discuss more on this in Android world. Basically, we want to discuss the coroutines, but now you have the idea about the coroutines, right? So we can continue in our Android world. So thank you everyone for joining. Have a good night. Bye bye. Take care.
No, thanks, Rajesh. Bye.